Let's go. So here's the beginning of assignment number 20. What are you asked to do in assignment number 20 is to find the area. So area in calculus is what type of question? Integration. So you have your piece of paper. We're doing review assignment number 20. So I know I need to integrate. I look back on the graph and I go, okay, which area am I looking for? It says area R. So R goes from what x value? 0 to which one? I don't know. So I need to know where the two equations cross, right? So we're going to use our calculator and we're going to see. If you don't have your calculator, like I asked you to bring it, then you can use Desmos or just watch. So I'm going to clear what I have. I'm going to go tab. I'm going to put in the first equation, which is 1/4 plus sine, and then inside is pi x. And then I'm going to put in the second equation and see where they cross. So I'm going to go tab, and the second equation is 4 to the exponent negative x. And can you see where they cross, even if it doesn't look exactly like the picture, right? Next, how do I find that point of intersection? The first one, menu, go to Analyze, and point of intersection is number 4. Move that to the left, press Enter. Move that to the right, highlight over it, and it's going to tell you that point of intersection. If you can't see the number, oh, you're a lot quieter when you know you're going to go on the internet. So, thank you. So, what is the x-coordinate of that point of intersection? And the answer is 0.178. So this is going to go from here to 0.178, and then it's top subtract bottom. So I want you to look carefully at the curve. Which curve is on top, and which one's on the bottom? On top is 4 to the exponent negative x, subtract. What's on the bottom is the longer trig one, 1/4 plus sine pi x. All right. If you use your calculator, I'm going to save you time because you can practice it on your own. This was the hard spot. You can actually practice it. It's 0.064 if you do it. That's part A. I'll give you a moment. That will forever be on the internet. Ivan saying hooray. That's not just this year. And Jaden saying he loves me. So that's not just this year. This video will be next year. Who knows how long I'll teach calculus. You never know. It could be like 8 years from now. They'll look at this video and know, right? So, oh, that was my cousin. That was my dad. That's the one that said it. You never know what they're going to say. Grandpa. Right? Like, who knows how many years in the future, right? That'll be. Years and years in the future. Part B. You never know. The next one, area S. How do I find it? So, I already know this one. What don't I know that I need to find is the other point of intersection. So, we're going to take out calculator again. You know how much I love talking over you. Press menu, analyze. And then intersection again is 4. This time I want the other one. So I'm going to press enter and then highlight across it. This one is an easy number. What's the x-coordinate there? Is 1. So it goes from 0.178 to 1. From 0.178 to 1. But now, which one's on top? 1/4 plus sine pi x. I can still hear you. Subtract the bottom, which is now 4 to the negative x. And then you would type that in your calculator. Now I'm going to save you time. You should practice it, though, on your own. That answer is 0.410 if you type that in. Part C. Find the volume generated when we're revolving. So if we're revolving, it's going to be pi. Which one? Am I doing R or S? Am I revolving? S, and it's around the line y equals what? Negative 1, which is down here. So it has two radius. What's the big radius? What's on the top? Subtract the bottom, all the way to the bottom. It's f at x subtract negative 1. So f at x is 1/4 plus sine pi x, and I'm going to subtract negative 1. When you subtract negative 1, you really are just adding 1, and you're squaring it. So pi r squared, again, this is top subtract bottom. That's for the big radius. How about the small radius? Still top subtract bottom. Go back to your graph. Tell me here for the little radius, now what's on top compared to the bottom? So 4 to the negative x, subtract negative 1, which again is adding, and this is what you put in. Oh, and the bounds go from 0.178 to 1. It's like part B, it's the same area region. This is what you type in. And if you type that in, it would be 4.558. Let's see. Well, let's try number 2. Let's see how far we get. Are you ready for number 2? Again, it's a calculator question. The tide removes sand. So R means removed at this rate. So this is already a derivative. 2 plus 5 sine 4 pi t over 25. When I see this type of question, eventually they're going to say how many, how much sand was removed, how much sand was put in. And when you see how much, what do you do with the rate? Is you integrate it. It may not be part A, but one of these parts is going to say how much, how many. And then we have a second one. A pumping station adds sand to the beach. So this one is adding it. So we have sand going away to the ocean and sand being put on the beach. And then part A asks what? How much sand? So I already have a sense. What am I doing with how much? Is I'm integrating it. How much sand will the tide remove? Just remove. During which? This 6-hour period. Which is 0 to 6. Which one is removing? And again, you don't have to write it twice, but you do have to type this in your calculator from 0 to 6, and I'll help you write. It's 31.815. Do we have units? Cubic yards. That means this. All right, part B. Write an expression for the total number of cubic yards of sand on the beach at time t. This question requires, is there any sand to begin with? So read carefully. Is there any sand to begin with? Yes. How much sand to begin with? Okay. Then, is sand being added? Say yes. Now, 0 to t means, I don't know what, if you just want any number from 0 to 6, you would integrate from 0 to whatever that number is. We're adding the part that's adding. Oh, sorry, that's not R, it's S. And then subtracting the part that is removing. And that's it. Just an expression to understand, did you start with it? Are you adding and then subtracting what's being removed? That's it. Then, part C. Find the rate at which the total amount of sand on the beach is changing at t equals 4. For this, you actually have to take the derivative of this. Find the rate, right? How's the rate changing? Is it increasing or decreasing? What's the derivative of what you just did? What's the derivative of 2,500? 0. What's the derivative integration? They cross out, plug in, right? It's just S at t. Take the derivative and you just plug in and it's just R at t. And then it says t equals 4. So then you just plug in 4. That means with your calculator, you would plug in 4, and subtract and see what the answer is. And if you'd use your calculator, you would notice there's a negative answer. So what do you know about the rate at that time? The rate is decreasing, right? All right, last one. Part D. From 0 to 6, at what time is the amount of sand on the beach a minimum? So minimum means a derivative, right? When we did that, took the derivative, right? This was the derivative, and then I want to make it equal to 0 to know what the critical number is. So we would use our calculator. You would go solve, and you would type this in and solve it and see what answer you get with your calculator. And if you did it correctly, you would get the answer 5.1178. So you go solve and type this equation in, comma t. This is the answer you should get. Then you draw a number line from 0 to 6. We could label it. And then you'd see, is the derivative positive or negative? Now, we already plugged in a number, 4. And when you plugged in 4, the answer was negative. On the other side, it's going to be positive. Where do we have a minimum value? When t equals that number, right? All right. That's it. What do you always say at the end of the video? Hooray. No. What is it? That's true. I do say that. Right, Mr. G Math, right? Over now. I'm proud of you for doing your work, right? Till next time.